What the heck is quantum computing, and should you care? Hi guys, Crystal here with D-News. I don't know if you've noticed lately, but there's a new wave of computer technology being quietly developed in basement labs and secret company offices. I'm talking about quantum computing. Companies like Google, Microsoft, and IBM, not to mention the US government, have started investing heavily in the development of quantum computers in the last few years, and news of their investments is slowly leaking out into mainstream media. So what is a quantum computer, and why are all of the major powers that influence our lives interested in them? Well, the short answer is that they promise to be faster, safer, and better at solving certain kinds of problems than our trusty laptops. That's only one part of the quantum picture. First off, let's figure out what it means for something to be quantum. Sometimes quantum is used interchangeably with small, but that's not really accurate. Quantum things are happening on all length scales all of the time. The distinction is that the likelihood that we notice these corrections on top of Newton's classical physics decreases rapidly the bigger we get. Weird. At the quantum level, a particle can teleport, travel backwards in time, be entangled with a distant cousin, and a hypothetical cat in a box could be both alive and dead at the same time. This apparently fantastical behavior is all possible because of science. Well, physics. And a little math. Most relevant to our quantum computing plot is the idea of superposition, which transcends classical deterministic outcomes, alive or dead, heads or tails, 0 or 1, to describe these states as a distribution of probabilities. The cat has a 70% probability of being alive. And as a funny outcome of the science, we don't get a fixed answer until we actually open the box and observe the cat, take a measurement of the system, or otherwise ask it for a specific output. A computer capable of exploiting this and other quantum properties like entanglement would not be constrained by a classical computer's need to perform calculations sequentially, because quantum bits would be capable of existing in a probability of many states, and thus be much better at tasks like simulating molecular bonds, performing rapid searches of complicated databases, or factoring large numbers very quickly. These examples may seem silly or irrelevant until you learn, for instance, that factorization is prohibitively time-consuming for a classical computer, which is why it forms one common approach to data encryption. Now quantum computers are looking pretty good, especially if you have an interest in national security. So how close are we to a programmable quantum computer? Not that close. You'll probably use one in your lifetime, but don't run out to find one at the store just yet. Research in this area is happening at a rapid rate, and has even resulted in the Nobel Prize for Physics in 2012. But scientists still have a long way to go. Challenges arise both from the difficulty in control and manipulation of quantum states, something that makes encoding quantum information very difficult, as well as the vulnerability of that information to disturbance from the environment. Nevertheless, scientists like those at Caltech's Institute for Quantum Information and Matter are working at the cutting edge of our current knowledge to make quantum computing a reality. And as for its potential, being able to simulate molecular interactions to create optimized materials on demand seems reason enough for Google, Microsoft, and IBM to throw tons of money at quantum computing. For as one scientist recently reminded me, who would have been able to foresee the impact of Facebook or the internet when classical computing was in development? What do you think? Will quantum computation change the world? Subscribe to D-News and let us know in the comments down below. And come find me on Twitter, @PollyCrystalHD.